So this is a typical example job script. Actually, this is not a very typical because this contains a lot more detail than you probably need. If you look at this job script, the bulk of this job script is the PBS directives. And there's only one little line down here where I'm running a serial program. So most of my job script is just telling the PBS system how to run my job. On this first line, I'm specifying the name for my job. The name for your job needs to be less than 15 characters. These are all my resource list lines, all these -L lines. Here I'm specifying 3 nodes. I want 4 cores and 4 MPI tasks on each one of those nodes. So I'm going to have 12 in all, 12 cores and 12 MPI tasks. The number of MPI tasks and the number of cores is generally always the same. Only in unusual situations, if you really know what you're doing, then you might change these numbers. But for the most part, the MPI procs should be the same as the number of cores, the NCPUs. On Palmetto, we have a few different types of network interconnects. And if you're using Miranet or InfiniBand, you need to specify that you're using that. Otherwise, you might land on nodes. Your job might be assigned to nodes that have the wrong type of network interconnect. So if you know you need Miranet, specify it in this way. If you know you need InfiniBand, you can specify it in a similar fashion. If you're using only Ethernet or you're not using internode communication at all, then you don't need to specify this. The memory specification is always per node. So in this example, I'm actually requesting 6 gigabytes of RAM for my total job. I'm getting 2 gigabytes for each one of the nodes that I've requested. I'm specifying that I want chip type E5410. Those are Intel Xeon cores. I'm setting a wall time of 18 hours. My job must finish within 18 hours. There's no way for us to extend a wall time. If you're running up to the wall time and it looks like your job is going to end early, sorry, there's really nothing we can do. You just have to run your job again and set a longer wall time. This line deals with how to handle my standard out and standard error output. I'll talk about that in another slide. Here I'm specifying a particular job queue. If I belong to the Fluix group and my Fluix group owns a particular job queue, then this is how I submit a job to that job queue. I include this line in my job script. And finally, this section deals with how I want the PBS scheduling system to communicate with me about my job, whether I want to be notified if my job begins, ends, or if my job's aborted. I'll talk about that in detail too. Finally, at the bottom of this job script is the command where I actually run the job. I'm running my program, I'm feeding in some input and creating a log file. The actual syntax you use here depends on your program. This is just a typical example, but your program may require very different syntax for its command. So as I mentioned, the standard out and standard error files. When you run a job on the cluster, and when you run any command actually, for example, just the date command. The date command produces output. And if I create some error, that also produces output. The output from regular commands, the output that's normally printed to the command line, is sent through standard out. And standard out, by default, is the command prompt. This type of output associated with errors, goes through the standard error data stream. And that also happens to be printed to the command prompt. Now, if you're running a job on the cluster and you're running it in batch mode, and your job is, for example, running it over the weekend, then you are not logged into a terminal window where you can see that output being printed to the command line. So the job scheduling system needs to have some place to send that output. And what it does is it creates these standard out and standard error output files that use your job's name as well as your PBS job ID number. That's the type of naming scheme they use. Your standard out will be printed to a file that looks like this, and your standard error output will be printed to a file that looks like that by default. Now you can control the way that output is handled. You can specify a particular error output file and a standard output file in this way. You can specify the path and the exact file name using the -E and the -O options. You can specify the -K option to keep those output files on your local host. In other words, those files will be kept in your home directory on Palmetto while the job is running, and any updates to those files will be updated in your home directory. Otherwise, you can use the -J option. The -J option will just join the standard error and the standard out files together into a single file. And this is what I typically do. It just creates a single output file, and without any of these other options, this will write the output file, which will look something like this. It will write that file in your work directory where you're running your job at the time when your job finishes. So that output file will not appear until the job completes, and then that file will be copied from the execution host to your work directory. If you're running a job and you want to preview that file, if you're not keeping it on the local host and you want to take a look at it, you can actually SSH to the nodes where your job is running. Let me show you what that looks like. So my example job is finished, but I'm going to start it again just so I can have a job appear in my job stats there. All right, so there's my job. It's all finished, but I'm actually just going to run it again. So there we go. And there it is. Now, I can use, if you recall from the MOTD, the message of the day, that I have this qstat-xf option to see detailed information about my job. Well, let's take a look at my job. There it is running. Let's run qstat-xf and use my job ID number. Let's see what that output looks like. It's a lot of information, and it's some very useful information, like the amount of memory my job is actually using and the nodes where my job is actually running. Those are the execution hosts. In addition to that, there's some other information like the time the job was submitted, the time the job started running, the location of the output files, all kinds of useful information. If you have a problem with a job and you contact the support team, this is exactly what the support team does. We look at the qstat-xf output for your job. Now, I can take that output and pipe it to grep host to just get the line that contains the execution host. And then I can SSH. While I have a job running, when a job is actively running on a compute node, I can actually SSH to that compute node and run commands on those nodes. So I'm going to SSH to node 1614 because that's the first one in this list, and therefore it's considered the master node of all the nodes where my job is running. So I'm going to SSH to that node. There I am. I'm logged into that node. And now I can cd to /var spool pbs spool and list the contents there. My job ID number is 5883136. And if you look, there's an output file there for 5883136. And I can take a look at that. And that's the temporary output for my job on the execution host. That's on the compute node where it's running. If I exit out of there and I go back to the directory where I'm running my job, I delete those. I delete that previous log file. see, there's no PBS output file there yet. It's because my job is still running, and that output file is still being stored on the compute node. Only when this job finishes running will that output file finally appear in my current working directory. All right, if you want to be notified by the PBS system about your job beginning or when your job ends, or if your job gets aborted, you can provide your email address with this -N, and you can use the lowercase m to specify under what circumstances you want to be copied. B is for when the job begins, E is for when the job ends and aborted, and so on. And this is what the contents of one of those emails would look like. This is an email that was sent to me after my job died. Oh no, actually this is after my job finished normally, so execution finished. And this is all the email contains, just lets me know what's going on. So if you want to receive those notifications, that's how you configure it in your job script.